Alright, example 4. The Golden Gate Bridge, a suspension bridge, spans the entrance to San Francisco Bay. Its 746-foot tall towers are 4,200 feet apart. The bridge is suspended from two huge cables more than 3 feet in diameter. The 90-foot wide roadway is 22 feet above the water. The cables are parabolic in shape. That's important. And touch the road surface at the center of the bridge. Find the height of the cable above the road at a distance of 1,000 feet from the center. Alright, I'm going to draw a picture of what they're talking about real quick. Alright, so this is kind of what they're talking about. I realized I made a mistake here. This should say it's not 22 feet above the water. It is 220 feet above the water. Okay, so the towers are 4,200 feet apart. So in order to be 4,200 feet apart from here to here, I go from negative 2,100 to positive 2,100. So this is 4,200 feet apart. Okay, the 90-foot wide roadway is 220 feet above the water. So if this is the water, this would be the bridge, 220 feet above it. The towers are 746 feet tall. So in order for this whole thing to be 746, if this is 220, this has to be 526 because 220 plus 526 is 746. So this is the graph that I'm going to use. Here's the bridge, here's the water, bridge, water, and it's parabolic in shape. Okay? So what we need to find is the height of the cable. The height of the cable above the road at a distance of 1,000 feet from the center. Okay, so let's say that, I don't know, let's say this is 1,000. I want to know what that height is there. What is this height when this is 1,000? So this is what we're going to do. We know that this is a parabola. So I'm going to use an equation, y equals ax squared. Okay? The reason I'm using y equals ax squared is because I know it is at the origin and it opens up. So I know a is positive, and I know it's not transformed or shifted in any direction. Okay? Now I know that, let's use this point here, that when y is 526, x is 2,100, or negative 2,100. Oops. Okay, so I'm going to solve this here. I'm going to rearrange it so that a equals 526 over 2,100 squared. Okay. I guess we could just leave it like that. So y is going to equal 526 over, let me erase that big parentheses. No need for it. (526) over 2,100 squared, x squared. I'll put these parentheses though. Okay. So the height of the cable when x equals 1,000, because this is the x-axis here, we want to know what y is when x is 1,000. So I'm just going to plug this in for x. Y equals 526 over 2,100 squared times 1,000 squared. And you guys all have calculators, so I'll just give you the answer. It's going to be approximately 119.3 feet. Okay, this is actually a pretty difficult problem, so I'm gonna draw the picture for you on this one for the you try. Okay. Let's see here. Actually, I'll just pause it and draw it. Okay, so this is very, very similar to this one, except that the towers are 400 meters apart. That's why I put it at negative 200 and positive 200. They are 75 feet above the road. They want to know what the height is at 100 meters from the center. Okay, so you guys can try that one. Alright, example 5. A farmer collected the data given in the table below, which shows crop yields Y for various amounts of X various amounts of X of fertilizer used. Okay, so use a graphing utility to draw a scatter diagram of the data. Alright, so what I'm going to do here is I'm going to pull out my calculator. I need to see the chart. Okay, let's get the calculator back out. Okay, so if you remember, what you're going to do is you're going to go to second, stat plot. You need to turn this on. Clear. Then go to stat, go to edit, and then just plug in the numbers here. So I'll just do that real quick. 1, 2, 3, whoops. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Okay, over here we've got, oh, whoops, sorry. Let's change this. This is your X, and this is your Y, not this column. This is just the number plot. Alright, try again. 0, 0, 5, 5, 10, 10, 15, 15. Oops, messed up. 15, 15, 20, 20, 25, 25, 30, 30, 35, 35, 40, 40. Alright, there we go. Now we've got number of bushels, so 4, 6, 10, 7, 12, 10, 15, 17, 18, 21, 20, 21, 21, 22, 21, 20, 19, and 19. Okay, there we go. So what I'm going to do is I'm going to change my window so that, let's see here, I can go from the X, I'll go from 0 to 45, and the Y's, actually let me change this to every 5. The Y's, let's see here, they're all positive. Let's make it from 0 to 25. And we'll go by 5s again. Okay, and we graph it. So this is what it looks like. Okay, you don't have to draw this. I just want to make sure you know how to do it, because there are a lot of things you can do with this. If you look at part B, use the graphing utility to find the quadratic function that best fits that models the relation between the amount of fertilizer and the crop yield. So if you look at our calculator, if you go to stat, go to calc, you're going to look for a quadratic regression model. So it's number 5. Go to vars, yvars, function, y1, enter. Okay, so this is the quadratic function we're going to look at. I'm going to write it down here. So y of x equals negative 0.0171 x squared plus 1.0765 x plus 3.8939. Okay, and if you look at your calculator, if you graph this, it will show you the best fit curve. Okay, now use the function found in part B to determine the optimal amount of fertilizer to apply. Okay, so basically what they're looking for here is they're looking for the maximum. And you guys all know how to find the maximum, so let's do it. I've got x equals negative b over 2a, which in this case is negative 1.0765 times 2 times negative 0.0171. This will give me approximately 31.5 pounds of fertilizer per 100 square feet. Okay, for part D, we just need to plug it in. So y of 31.5, negative 0.0171 times 31.5 squared plus 1.0765 times 31.5 plus 3.8939. And this will give you approximately 20.8 bushels. Okay? You know what? Don't worry about drawing it. As long as you can do it on your calculator, that's fine with me. Okay? If you want to draw it, you can, but don't worry about it if you don't want to. Alright, I will leave the you try for you to do, and that's all.